Hi, and welcome back to Tech Rems. Today we are going to talk about database normalization and the various forms of anomalies that can occur when a database is not normalized. We will go through the normalization steps to normalize a database from first normal form to third normal form. Please subscribe to the channel if you haven't subscribed yet. If at any point you find this video helpful, just hit the like button. Let's get to it. What is normalization? Normalization is a formal process for grouping related attributes in a relation. In other words, it is the process of decomposing relations with anomalies to produce smaller and well-structured relations. The main purpose of normalization is to reduce or minimize data redundancy in a database. What do you mean by data redundancy? Data redundancy occurs when you have multiple copies of the same data stored in more than one place at a time. And so that is what normalization seeks to avoid in a database. There are other purposes of normalization, such as it makes it easier for the user to access and maintain the data. It also helps to take up minimal storage on the computer because there will not be redundant data. I mentioned that normalization is the process of decomposing relations with anomalies. What then is an anomaly? An anomaly refers to an unexpected and undesirable occurrence that can arise when the database is not properly structured or organized. Now, we have three types of anomalies. They are insertion anomaly, update anomaly, and deletion anomaly. When does insertion anomaly occur? It occurs when it is not possible to insert data into a database without also adding other data that may not be relevant or available. Let's take a look at this table for illustration. To insert the details of a new branch that currently has no members of staff, it's necessary to enter now into the staff relation columns like staff number because it's not available. However, as staff number is the primary key for the table, attempting to enter now for staff number violates entity integrity and is not allowed, and so you have insertion anomaly. Now, update anomaly occurs when modifying data in a database results in inconsistency or errors in other parts of the database. Using the same table, if we want to change the telephone number of branch B001, we must update the records of all staff located at that branch. And so, if we had 100 staff at branch B001, we must update them individually. And if care is not taken, there will be errors and inconsistency. That brings about update anomaly in the database. Now, deletion anomaly also occurs when deleting data from a database unintentionally removes other data that should have been retained. In our table, if we delete the record for staff at Peters with staff number S0415 from the table, the details relating to branch B003 are lost from the database. Since that branch only has this staff, we didn't intend to delete the branch related data, but it's deleted, and so there is deletion anomaly in this table. To overcome these anomalies, we need to normalize the data or the table. Normalization is accomplished in stages, from first normal form to second normal form, then to third normal form. There are other advanced normal forms, but these are the basic forms. Starting with first normal form. For a relation or table to be in the first normal form, it must follow these basic rules. 1. The relation should have a unique identifier or primary key. 2. Each cell must contain a single value. That's the principle of atomicity. 3. Each column should contain values of the same data type. And 4. Each column must have a unique name. We are going to normalize this table with the steps we go through. So let's check it with the first normal form rules. What is the primary key for this table? A primary key is a value or attribute that uniquely identify each row. Now, we can't use other ID because it doesn't uniquely identify each row. Same applies to almost all the attributes. But you will realize that if you combine other ID and item number, each row will be identified uniquely. There is no combination of order number and item number that are the same, and so that becomes the primary key for this table, and is a composite primary key as it consists of more than one attribute. So we have a primary key for the table, and that is check. Does each cell contain a single value That is a yes, and checked. Does each column contain the same data type? Yes, so checked. Finally, do we have unique names for each column? Yes. At this point, our table is in the first normal form. Let's go to the second normal form. For a relation to be in second normal form, it must fulfill these two conditions. First, it must be in the first normal form, and then it should not have partial functional dependencies, meaning it should have full functional dependencies. Let's explain what functional dependency means. Functional dependency is a constraint between two attributes in which the value of one attribute is determined by the value of another attribute. If A and B are attributes of relation R, B is functionally dependent on A if each value of A is associated with one and only one value of B. It is represented as A arrow points to B, meaning for you to get the value of B, then you must know the value of A. And A here is a primary key, either single attribute or composite, and is called the determinant. So B is fully functionally dependent on A if B is functionally dependent on A and not a proper subset of A. This is in the context of composite primary key. The attribute must depend on the entire key and not part of it. We will see that in later parts of the video. So let's check our table by the second normal form rules. The table, of course, is in the first normal form. We just did that. So that is checked. It means that before you continue with second normal form, you might have fulfilled first normal form conditions. Now the second rule says there should not be partial functional dependencies. Now that we understand what functional dependency is and what it means to be fully functional dependent, looking at our table, are there attributes that are not fully dependent on the primary key? You guessed right, there are. We can see that the item description and price depend only on the item number. You don't need the order ID to know an item's description or price. However, the quantity ordered can be said to depend on both the order ID and item number, because it tells how many units of each item was purchased for a specific order. So the values of item description and price depend on parts of the primary key, that's item number, and so there is partial dependency. So we move those attributes with the attributes they depend on to a new table and name it item, and here item number becomes the primary key, and it will still be in the order detail table as a foreign key and also part of the primary key. You see that in the item table you don't have repeating items, even though the item number is repeating in the order detail table. Wherever you see item number 4011, it represents the description and price in item table. Now, do we still have any partial dependency? Yes. The date, customer ID, customer name and region do not depend on item number. You only need to know the order ID in order to know the date the order was placed, the customer who placed it. So they partially depend on order ID and not item number. So we put them in a new table and name it order. The primary key will be order ID here. It will also be in the order detail table as a foreign key to link the tables. So now we have three distinct tables, all attributes in each table fully functionally depending on the primary key, and the tables linked by foreign keys. There is no partial functional dependency, and therefore there are full functional dependencies. Moving on to the third normal form. A table must fulfill these two rules to be in third normal form. First, it should be in second normal form, and then it should not have transitive dependency. What is transitive dependency? If A, B, and C are attributes of a relation R, such that if B depends on A and C depends on B, then C is transitively dependent on A via B. Let's look at the table. When you check the order table, you realize that customer ID depends on order ID. Of course, you need to know the order ID to know the customer who placed it. But then, customer name and region depend on customer ID. So transitively, these two depend on order ID. And that is what we are removing in third normal form. So we move the customer name and region with the customer ID, which will be the primary key to a new table called customer. And that will hold the customer details. And we'll have the customer ID attribute in other table as a foreign key to establish the link between them. At this point, there is no transitive dependency, so our table is in third normal form. And now we have a normalized database relation in third normal form from an unnormalized relation. So if we go to order detail table, we get the order ID, the ordered item number, and the ordered quantity. If we want to know the date and who placed any of the orders, the order ID will lead us to the order table, and the customer ID here will tell us the details about the customer from the customer table. Also, let's check if there can be any anomaly here. If there is a customer who just subscribed but haven't ordered yet, you just add him to the customer table, and that's all. No insertion anomaly. You don't need to insert in any of the tables again. Also, if you want to change the price of item 4011 from 35 to 45, you change it once in the item table, and wherever there is item 4011, it corresponds to price 45. No update anomaly anywhere. If we delete the last order detail, we don't lose data about the item ordered or the order placed. So no deletion anomaly, unless of course we want to delete the order from the order table. Now try this on your own. Normalize this relation from first normal form to second normal form and to third normal form. If you have any question or concern, leave them in the comment section below. Thank you for watching, and please don't forget to subscribe if you haven't subscribed yet. See you in the next video.